Hey Mathora fam, welcome back. Today we are diving into the exciting world of related rates. Have you ever wondered how fast the water level rises as you fill a tank? Or how the shadow of a moving person grows? That's all related rates in action. Let's break it down and solve some real world problems step by step. Ready? Let's go. So, what are related rates? Simply put, related rates are about figuring out how two or more quantities change with respect to time. For example, if the radius of a balloon increases, how does the volume change? The key is that these rates are connected through some equation, and our job is to figure out one rate when we are given another. Sounds cool, right? So here's the step-by-step process to solve real-world problems. Step number one, identify the variables. What quantities are changing? You need to label them. If it is um, A equals 5r squared, if r is the one that's changing, then you need to label them. Step number two, write the equation. Find the equation that connects this variable. As an example, you can see A equals 5r square, which is the equation for the area of a circle. Step number three, differentiate with respect to time. You need to use implicit differentiation to find how the variables change over time. And you should not forget to include d over dt for every variable. And as the last and the fourth step, you need to substitute values. So you need to plug in the given numbers and solve for the unknown rate. So let's see it in action. So I'm moving into example one. Okay. So now let's read. Imagine water is being poured into an inverted cone, and we know the water level rising at dH over dt is 3 centimeters per second. Seconds. How fast is the volume of water increasing when the height is 12 centimeter? So let's write a, first of all, let's draw an, draw an image. This is the cone, and it says this a water is being poured into an inverted cone, and we know the water level rising is at dH over dt, which is equals 3 centimeters per seconds. And how fast is the volume of water increasing when the height is 12 centimeters? So this is the height, this is the radius, this is the height. When h equals 12 centimeter, they're asking how fast is the volume of water increasing. Okay. So step number one, we need to write the formula for the volume of a cone. So it's going to be V equals 1 over third times 5 r squared times h. Step number two, relate r and h. If the cone's radius and height are proportional, then we need to substitute r into the equation. So that's going to be r equals h divided by 2, as because the radius and height are proportional. So then we can substitute like v equals 1 over third times 5. This is going to be h divided by 2 times squared times h. And it's going to be v equals 1 third 5 h to the power of 3 divided by 4. And the final answer is 112 times 5 times h to the power of 3. Okay, step number 3. We need to differentiate both sides with respect to time t. With respect to time t. So we can write like this. dv over dt is equals, as we know 1 over 12 times 5 is a constant, so we can write it like 1 over 12 times 5 as it is. Then you need to differentiate h to the power of 3 with respect to t. So it's going to be 3 times h to the power of 2 times dH over dt. So now we need to substitute all the data that we have. As we all know, we have h equals 12 centimeters and dH over dt equals 3 centimeters per second. Now we can substitute it. 1 over 12 times, 5 times, 3 times h to the power of 2, that means 12 times 12, then again 3. So if we calculate 1 divided by, okay, just give me some time, 1 divided by 12 times 3 times 3 is 9 times 12 is 144. Yeah, so the answer is going to be 108 times 5 cubic centimeters per second. So the volume is increasing at 108 5 cubic centimeters per second when h equals 12 centimeters. Okay, easy, right? Okay, so let's move into our second example. Okay, here we go. So this is also another classic related rates problem. So, okay, now let's read. A 10-meter ladder is leaning against a wall. Like, let's imagine like, okay, this is a wall. Okay, I will draw it with dotted lines. This is a wall and this is the ground and this is the ladder. Okay, so let me write like this. This is the wall. This is the ground. Okay, a 10-meter ladder is leaning against the wall and the bottom is sliding away at dx over dt equals 2 meters per second to this direction to right. And the question is asking how fast is the top of, this is the top of the ladder sliding down when the bottom is 6 meters from the wall. When they are asking when x equals 6 meters, they are asking how fast is the top of the ladder sliding down when the bottom is 6 meters. So this is going to be y. Oh. Okay, now let's solve. So step 1, as we all know, this ladder is 10 meters long, like this. Now we can see the Pythagoras theorem in this question. So we can write like x to the power of 2 plus y to the power of 2 equals 10 to the power of 2. Okay, step 2. We need to differentiate both sides with respect to time t. Remember, with respect to time t. So it's going to be 2 times x times dx over dt plus 2 times y times dy over dt, and 10 to the power of 2 is a constant, so it's going to be 0 after differentiating. So then now we have a formula. Now we need to isolate dy over dt. That's what we are expecting, because we are expecting how fast is the top of the ladder sliding down. So we need to find dy over dt. So dy over dt equals negative 2x times dx over dt. I made a mistake. Sorry. It's not the way that we write. So it's going to be negative 2x times dx over dt divided by 2y. So dy over dt equals negative x times dx divided by dt divided by y. Okay, now we need to find y when x equals 6, because they are asking all the answers regarding x equals 6 meters. So we need to find when x equals 6 meters, y is, as we all know, x to the power of 2 times y to the power of 2 is 10 to the power of 2. 6 to the power of 2 plus y to the power of 2 is 10 to the power of 2. So y is going to be 8 meters. Okay, now we need to substitute x equals 6, y equals 8, and dx over dt, that is 2 meters per second. So let's substitute them all here. So negative 6 times 2 divided by 8. So as you all know, 2, 4. For 6 and 4, it's going to be, we can divide this by 2. That's mean 2. And this is as 3. So 3 divided by 2 is negative 1.5. And it's going to be meters per second. So the top of the ladder is sliding down at 1.5 meters per second when x is 6 meter. So let's recap. Related rates problems are all about finding how quantities change over time using their relationships. As we all, as I all said before, step number 1, write the equation connecting the variables. Step number 2, differentiate with respect to time. Maybe you need to use implicit differentiation. And step number 3, plug in values and solve for the unknown rate. So that's it for related rates, guys. So if you felt like this video helped you to understand what are the related rates and the applications, and just give a help to us, subscribe our videos, subscribe to our channel, and give a thumbs up and share it with your friends, and it's a lot to me. And in the comment section you can ask many questions, or if you have any doubts, if you have any suggestions, if you feel like that you are not confident with a relevant topic, then you can request from us, and we are so happy to teach you. Yeah. And always remember, I would like to say, repetition is the mother of learning. So you need to practice these questions as much as possible to get better. Okay, then until next time, see you. Bye bye. Have a wonderful time, Mathorians.